Good afternoon.
Good afternoon, sir.
Good afternoon. Good afternoon.
Good afternoon.
নজন কোথায় বাকি? Okay. স্টার্ট করছি, ঠিক আছে? So the next new topic, that this is the relational algebra, right? Um, শুনতে পাচ্ছ তো সবাই?
Yes, sir. Yes, sir.
Yeah. Already we are familiar with that SQL, right? SQL, that structured query language, right? So now, so what is the query language? So what is the query language? Now this is the language which allow manipulations, right? Which allows manipulations and retrieval of data in a Dbms, isn't it? From database, right? So this is the query language, right? Though this is what? This is the query language, that what we know. So now relational models, we are dealing with the relational models, right? আমরা জানি যে that because this is very easy to represent everything, so we are dealing with what? We are dealing with the relational model, and this supports a very simple and powerful query language, right? And this query language, that doesn't mean that it is the programming language. Means if you think about the query language, this is not that programming language, that you cannot say, right? Because the query language is not used for the complex calculations. We cannot use that query language, right? It's very easy, and it is simply accessing the data from the database. Either it's a manipulation of the data or the retrieval of the data. Clear? Means it's solely dealing with the data only. So this is the query language. Now, if you think about the relational query language. So this relational query language are what this is depend on this query language are the, you can say that this query language are the basis for real language like SQL. So SQL is what? This is the query language. SQL is what? This is the programming language, right? This is the programming language, and where it is easy to, we are writing that SQL. But these are the relational query language, or these are the mathematical query language. Means here we are using the concept of the procedural form, means where you can do the step-by-step operations, right? And in relational algebra, it is taking the relation as an input and it is giving the relations as an output. Am I clear? Is it clear? Hello?
सर एक बार थोड़ा फिर से बोलिए, उनका लेट टाइम सर अलग बार बोलूं.
The relational algebra, the query language is the programming language. SQL is the programming language, right? And the relational algebra, that what we will write, that this is the relational algebra, and the relational calculus. So this relational algebra, relational calculus, these are what? These are all query language, relational query language, and these are helping for the programming language. So that's why these are known as the basis for the real language, or the base of the real language, the programming language, which is the SQL. Means if you can understand the relational query language, if you can understand the relational algebra, relational calculus, so it will be very easy to write the programming language, right, for the query retrieval or for the data retrieval. So means if you know the relational algebra very well, so it will be easy for you to write the code in SQL if you know the syntax only. Clear? So this relational algebra is what? This is a procedural query language. Here we are doing the step-by-step process. Means module-wise we will do the work. And relational algebra is taking the relation as an input, that I will show you. They are taking relation as an input and they are generating again a relation as an output. Okay. Clear?
Yes, sir.
But in the other hand, the SQL. SQL is what? This is the declarative. Declarative means you need to write the query to tell the DBMS that what you want. Either you want all the row or you want some particular row. Like we have done already the SQL statement. So in SQL, you need to say to the DBMS engine to process that query to get some desired result. Right? Means here we are not saying how it is to be calculated. It is written that, which means you tell the DBMS what you want but not how it is to be calculated. Clear?
Yes.
Yes, sir.
But in relational algebra, you have to say, you have to write the step-by-step process, which is that's why it is another procedural, because we have done the C++ code, right? We have done also the Java code. So these are all procedural programming language. These are all procedural programming language. What is the meaning of the procedural means what? That here you need to write the, not the procedural programming language, sorry, Java is object oriented, means they are following the procedure. Simply they are following the procedure, either it's a C code or it's a C++ code or it's a Java code. Simply they are following some procedure, right? Means some step-by-step process is there, and after that you are getting the result at the last step, right? So that's why they are known as the procedure oriented. This procedures are follows there. So here also in relational algebra also we are emphasized on the procedure rather than the declarative. That's why relational algebra is more procedural than SQL. And it's basically, simply you can say it's a mathematical expression. Means it is related with the maths, right? Means it's like that you are doing some mathematical calculations, mathematical operations with the relations. That also you can say. Is it clear? So like maths means like algebra, means if you give the analogy of the relational algebra with the normal algebra, so it has also some operators, like means operators are basically means what? It takes the operand. So here also the operands are there, and the operands are basically here the relations, because here we will deal with the relations, right? So same two types of operations are there, operators are there. One is the basic, another is the extended one. Under basic there are two operators are there. That unary operator means which will take, unary means it is taking one operand, তাই না? এটা তো জানো, unary operator, binary operator means in maths the increment operator, the decrement operator, so these are all unary operators, right? Binary operator is what? Addition, subtraction, so these are all binary operators, means they are taking two operands, isn't it?
Yes, sir.
So here also we have the unary operators and the binary operators. Unary operators means they are taking the single operand. So projection operator, selection operator, renum operator, so these are all unary. Binary union is there, cross product is there, minus is there. Some derived operators also there, which are known as the join operator, division operator, intersection operator. So they are all the extended operator. We will cover all the operators, right? So the first one is what? This is the relation operator. This is what? This is the relation operator. Sorry, select operation. So this is basically what? This is the what? This is the unary operator. Means it will take only one relation as an operand. কি বললাম? It will take one relation as an operand. Clear? So the select operation simply used for selecting tuples that satisfy a given predicate. Predicate means that you can say the conditions. That you can say simply the conditions. Okay. In relational algebra, the conditions are known as the predicate. This is actually known as the predicate. Sorry, 1 second. Some mistake is there. Just wait. So the select operation is what? It is actually selecting the tuples. Means if you want to select the tuples, particular tuples means the rows, right? So it is selecting the tuples which satisfy the given predicate. So what is the predicate? So here the notation is sigma. The notation is what? The notation is what? This is sigma. So this is the sigma notation. This is the ultimately this one. So this P is known as the selection predicate. Means what you will write here means that conditions what you will write. This is known as the selection predicate, or you just simply say that this one is the predicate. Means you are doing the selection operations. This is the logic. This is what? This is the logic or the conditions you can say. This is the logic or the propositional logic you can say. Right? This is the selection predicate. Right? And this is the relation. बहुत बार हम की बोलছি This is the selection predicate, sigma. It is denoted by sigma. Okay. This is what? This is the selection predicate that you can say, the predicate. This is what? Simply we are telling these are the conditions, but the good name is what? This is the proposition logic, based on which you will select the tuples. কোথা থেকে পাবো? From the relations. It will take the relations. Is it clear?
Yes, sir.
Yes, sir.
Okay. So now I have one table, instructor table, right? And in this instructor table, I have one table. So the question is that select those tuples of the instructor relation where the instructor is in the physics department. So this is the query. This is the query. So in SQL you can familiar with that, because there we have done this with the where condition, isn't it? মনে পড়ছে?
Yes, sir.
Yeah. So here how we will do? So I need to select those tuples of the instructor relation. So I have taken the instructor relation within the bracket. So this will be sigma. What is the condition or what is the proposition logic? The department is physics. So the department name equals to physics. So whatever you will write, this will be in double quote. Means if you write any string, so this will be inside a double quote. Right? If you are using any string, that will be in double quote, and if you want to use any numerical, so it will be simply write as it is. In SQL, whatever you are writing in the single quote, here you have to write within the double quote. In SQL, we are writing the varchar within single quote, isn't it? করি তো আমরা. Hello.
Yes, sir.
Yeah.
Yes, sir.
Here we are
Yes, sir.
representing the string inside the double quote. So this is the difference. So after that, you are getting this output. Okay. It also supports all the comparison operators that what we are actually using. Means you can use that equal to, not equal to, greater than, less than, equals to, greater than, equals to, less than, equals to, everything. It also support all the uh, digital sorry that all the logical operators also. It also supports all the logical operators like logical and, logical or, logical not, everything. Okay, whatever you have done in SQL. So this is the language part, and this is the mathematical expressions that you can say. So here we have the another query that find the instructor in physics with a salary greater than 90,000. So you need to use two logic, you need to implement two logics, right? One is what the department name should be physics, and the salary also should be greater than 90,000. Okay, so what will be the query? Hmm? One second. So what is the query? So this is sigma, means we are selecting that tuples based on this logic and this logic from the instructor table. Okay, you can compare also between two attributes, right? Means you can compare the two attributes also. So here is the, this is also one attribute, this is another attribute. This is not the value, right? Like, because value is always will be in double quote if it is a string, or if it is a digit, simply you need to write this. So here we are comparing two attributes. Means find all the departments whose name is same as the building name. Okay, means department is also one attribute, and building is also another attribute. So here we are just comparing two attributes from the department table. Okay, selection operation is commutative. Operation is commutative, means this one means if sigma A and B, so this is sigma B and A, so all both are same. Okay, the number of rows written by the selection operation is obviously less than or equal to the number of rows in the original table. So this is obvious, means whatever the row you are getting from after the selection operations, so either this is equal to the number of rows what you have in the original table, or it is the less than. So the minimum cardinality is 0, because what the conditions you have given, so no row is returning, right? So that's why the minimum cardinality is 0, and maximum cardinality is what? The number of row in the relational table. Is it clear? Just check it that it is clear or not, or if you are in doubt, then ask me. Bolo, is it clear? because relational algebra is very crucial, means, and this is coming in the exam also. Exam কিন্তু আসে relational algebra, মানে its option means either relational algebra will come or the SQL will come or both will come, অনেক সময় দুটোই একসাথে আসে, কিন্তু কোনো না কোনো একটা থাকবেই মাস্ট, either SQL query থাকবে or relational algebra থাকবেই মাস্ট. Any question till now?
No, sir.
বাকিদের?
No, sir.
No, sir.
No, sir.
তিথি বুঝতে পেরেছো? স্নেহা ইটস ওকে, সঞ্চিতা, পল্লব,
Sure.
নাফিজা ঘুম ভেঙেছে?
Yes.
অবদীপ্ত বুঝেছো?
Yes, sir.
Okay. So I'm going to the next part. So this is the projection operation. So remember, the selection operation is selecting the key. Selecting what? Selecting the key. Selection operation selecting what? বলো?
The tuples.
Tuples or the rows. ঠিক আছে? Projection operation is opposite to it. Projection operation is returning the columns, বা যেটাকে আমরা ভালোভাবে বলি it is returning the attributes. আমরা অলরেডি করেছি এটা, কারণ আমরা করেছি না সিলেক্ট স্টুডেন্ট নেম, মানে এই সিলেক্টের সাথে ওই কোয়ারি সিকুয়েলের সিলেক্ট একটু আলাদা. ইন এসকিউএল if you write select student name or select star from table name যদি করো, then you are getting actually all the columns here also. So this is basically the implementation of the project operation, and when you are giving the where condition in SQL, so this is the implementation of the select operation of relational algebra. Clear? So the project operation is doing what? So it help to extract the values of a specified attribute, and it also duplicate the it's also eliminate the duplicate values or the any, yeah, it's just simply it's giving the unique values, right? So this is done by the notation is pi. This is what? This is pi. Okay, so here these are the name of the column, so these are the attributes names. This is the name of the relation. Duplicate rows removed from the result since the relations are sets. Okay, so this is the notation, means you have to write pi, then you need to write the name of the attribute that which you want, and inside the parenthesis you have to write the name of the relation. So this is the question, this is the example of the, so what I am getting, that I want only the ID, name and salary from the instructor table, right? And in the another part you can say that in another, that you are just eliminating other attributes. That also you can say that if you want to eliminate some attribute, you are using the project operations. So in other word also you can say. Clear? So here the question is, the eliminate the department name means you are considering the other attribute. So to consider the attributes, you can say you are using the project operation, or to eliminate some attribute, we are using also the project operations. So you can say any one of these words. Am I clear?
Yes, sir.
So you can say that project operation or the projection operation is used to select required attributes, or you can say it is used to eliminate some attributes from the relation. Okay. So this is the combination of selection and projection operation, select and project operations. So the selection and projection operation. So what is the condition? This is that find the name of the instructor who are in physics department. Right. So find the name means what? I want the attribute. This is pi name. Okay. Now what is the condition that I want that instructor who are from physics department? So for conditions we are using the select operator, isn't it? So again we have started the bracket select operations and then the relation name. Is it okay? Select operation is not commutative obviously because what you are selecting like this is not actually the commutative one. Okay, so just remember this is not commutative. And suppose you are writing pi name, then again you are writing something pi like suppose roll number equals to so pi roll number, again suppose you have some conditions with that pi. Okay, so this is not equals to that pi roll number with conditions, again you are bracket you are writing pi, so both these are not equal because you are selecting the attributes based on some conditions. Clear? So that's why it is not commutative. Any question? Any question? কোনো কোশ্চেন থাকলে বলো। সবাই কি ঘুমিয়ে পড়লে নাকি?
No, sir.
আছে কোনো ডাউট আছে কারোর?
No, sir.
Okay. So next one is the Cartesian product. Cartesian product, it is denoted by, is a very common notation, is the multiplication sign. Right? That what we use in the mathematics. This is the notation of the Cartesian product also. So it is means if you have two relations like R1 and R2. Suppose you have two relations R1 and R2. So the Cartesian product of these two relations, is giving the all possible combinations of each tuple of relation R1 with each tuple of relation R2. Am I clear? The Cartesian product of two relations the Cartesian product of two relations is the all possible combinations of each tuple of relation R1 with each tuple of relation R2. Right? It is given in each possible pair of tuples. Okay? And if the attribute name is same in both the relations, if the attribute name is same, suppose ID. So if the attribute name is same in both the relations, so it is difficult to check or to find that which ID is from which relation. Right? So that's why what we are doing, we are writing simply the name of the relation before that attribute. So this is the notation. In SQL also we will use that notation. In SQL same notation use korbo, means if the same attribute is present in both the relations or in both the tables, so to make it unambiguous, to make any to avoid any confusion, we simply use the name of the relation before that attribute. Right? And this is the notation that instructor dot id. So we are using the dot operator here also. So when it will write, so it will show you, it will make you understand, or it will that this id is from instructor table and this id is from the teachers table or the teachers relation. Is it clear? And this is the all possible combinations.
Yes, sir.
Okay. The join operation. The notation is same. The notation is same. But some difference is there with the join operation. Right. কি ডিফারেন্স থাকতে পারে মনে হয়? Join operation is also the one type of Cartesian product operation, but in Cartesian product what you have seen that it is giving you all possible combinations of the tuples of one table with another table, right? But in join operation, here the combination of the Cartesian product followed by some certain condition. it is followed by some certain condition. Am I clear? If and only if that condition is satisfied, then only the join operation is possible. So if you look at this table and if you look at that table, then you can see the difference. This table is huge, and for each possible combination of that one, I am getting everything, all this. But here you can see a very limited number of rows, and this is because of only these conditions. Means if the ID of both the table are same, if the ID of both the tables are matched, then only you will get that possible combinations of the tuples. Am I clear? Am I clear?
Yes, sir.
So now so that what I told you. So this is there. You can write also in this way also. So this is another notation. That this point I am coming later because this is the theta join. So I am just coming later because I will explain this. So this is the notation. Means in this way also you can write that sigma instructor ID, and within bracket you can write the this, or you can write in this way also. So whichever is easy for you, you can write. So this is the notation of the join. This is actually the equijoin, or you can say the inner join also. Okay. So these are the types of the join operation. In means logically, I will show you through the Venn diagram also. So these are the different types of join operation. So these are basically of two types, right? These are basically of two types, like inner join and the natural join. Sorry, inner join and the outer join. Okay, and this inner join are of three types. You can say there's a theta join, equijoin, natural join, and outer is the left, right, and the full outer join is there. Inner join is used to return tuples from both the relations or from both tables which satisfy the given condition. Is it clear? Simply, inner join is what? It will return that tuples or those tuples which those tuples from both the tables which satisfy a given condition. So this is the inner join. Clear?
Yes, sir.
In this inner join, we have three joins. This is the theta one, equi, and the natural one. So theta join, if you consider about the theta join, what it is actually, it is allow you to merge two relations based on the condition represented by this theta. Theta is basically is representing the condition, right? Theta is representing basically the condition. Am I clear? So this is the notation. This is actually the notation. This is means this is the notation of the joining. So theta is basically is giving the condition. Okay. So this theta is what I tell you that theta join can use any conditions in the selection criteria. Means it also supports the all the comparison operators also. It also supports all the logical operators also. Right, just remember this sentence. Theta join support all the logical operators as well as support all the comparison operators also. Right, এটা কিন্তু মাথায় রাখতে হবে। Equi-join. So here you can see that we have used the greater than operator. That operator we have used here. So suppose I have two tables. ধরো আমার কাছে দুটো টেবিল আছে। If we use the Venn diagram of this, so if we use the Venn diagram of this, so it is simply notifying this one, right? This one. This is the inner join. Okay. So if you simply just suppose I have the column 1 and I have the column 2. This is the relation A, suppose. So suppose I have 1, 1, 1, 2 like that. Or suppose I have another, this is B, this is column 1 and column 2. And here also suppose I have 1 1 and 1 3. So if you do these operations, if you do this operation, then what you will get? What you will get? What will be the resulting table? What will be the resulting table? Hello. So ঘুমিয়ে পড়লে নাকি?
No, sir. No, sir.
So what will be the resulting table? Can I write this? কি হলো সব কি ঘুমিয়ে কি ব্যাপার? Column 2 is greater than means A dot column 2, A dot C2 is greater than B dot C2. This is the condition before the join operation. I mean, this is the condition, right? That A dot C2 should be greater than B dot C2. This is the condition. So only this one is satisfying the conditions. And obviously the value of the C1 is 1. So that's why you are getting the 1, 2. Okay.
Yes, sir.
Okay. Any doubt? Any doubt? about ওকে ঠিক আছে তাহলে ক্লাস এন্ড করি ঠিক আছে
Okay, sir.